Welcome back to NANDGAME. We are on to switching. And first up is the selector. The select component selects one out of two input bits for an output. The S select bit indicates which input is selected. If S is 0, D0 is selected. If S is 1, then D1 is selected. This is also known as a multiplexer, which is a much more fun word to say than selector. And like everything else we've done so far, there are multiple ways of solving this. We could go through each one with our 3 AND because we got 3 inputs and 1 output. We could look at where the output's 1, and we could say not S, not D1, and D0, like this. And then this covers this section of the truth table. And we could keep going to get the rest of them, but we can actually make it a lot simpler. So the truth is, if S is 0, we don't actually care what D1 is, and if S is 1, we don't actually care what D0 is. So we can look at this, and so we can say if S is 0 and D0 is 1, then the output is always going to be 1. Doesn't matter what D1 is. So not S and D0, we output 1. So not S and D0, and we'll output 1. Or if S is 1, then we don't care what D0 is. So we can say S and D1. We can OR them together. And there we go. This should work. 4 components used, and we have used the fewest components possible, though potentially we can make it more efficient than that. Next is the switch, or De-Multiplexer. A switch component channels a data bit through one of 2 output channels. The selector determines if the data bit is dispatched through C1 or C0. So depending on whether this S is 1 or 0, this D input will either go to C1 or C0. And I think this is much simpler. We can use our tried and true method. We can look at just one output at the time. So let's just look at C1, and then we're only caring about where 1 is as part of that truth table. And the only spot is right here, and that's when S is 1 and D is 1. And together S and D, and output it to C1. And then we look at C0, look at where it's 1, and the only spot is right here, and that's not S and D. So we're going to invert S to get not S, hook that into A, and then in the B slot, we're going to hook in D, and then output that to C0, check solution, and there we go. We got it again with the fewest possible components. So these are very important in our final computer, our final circuit. We're going to use the switch and the selector, or the multiplexer and demultiplexer, as a method to select and route data to where we need it to go. But you can see they're pretty simple to put together. They're nothing too complicated. And that's it for switching. So that was a really short section. So how about I use this time to make 3 suggestions if you want to learn more about circuits and computers and how that all works. Number 1 is a course called NAND to Tetris Part 1. It's on Coursera. It's totally free. I think if you want a certificate, it costs a little bit of money, but you don't need the certificate for anything. You can just run through all the course material and do all the coursework on your own. Part 1 covers pretty much what this game covers. It starts you off with a NAND gate, and you learn to build all these components. And Part 1 ends with you creating assembly and using assembly code. There is a Part 2 to the course that's much more software focused and much more focused on programming, where you deal with a virtual machine language and create a virtual machine translator, and you create a compiler. And at the end of Part 2, you're able to program a Tetris-like game on the computer that you built. But Part 1 is really where I'd focus. I think Part 1 is like a really amazing course. So if NANDGAME interests you, then you will definitely like that course. Number 2 is the book Code. Again, it covers pretty much the same thing, just in more detail. And this is, of course, a book, so you kind of build your computer on paper, which is fun, and it gives you a lot of historical details. Really enjoyed that book, highly recommended. And finally, there is another game called Turing Complete, which is kind of like a more polished version of the NANDGAME, I suppose. It covers a lot more, and you end up doing assembly challenges, and you end up building a more advanced processor. I really enjoyed the game. I actually did a whole walkthrough, a whole playthrough of that game. I will link that in the description. But that does cost money. That game costs money, whereas NANDGAME that we're playing here is totally free. Obviously, you just play it right in your browser. So if you're liking NANDGAME, if you're interested in NANDGAME and you're interested in learning more, those are the resources that I'd go to. But that's it for now. That's all I've got. So next time we will work on the arithmetic logic unit, aka the ALU. which will be the heart of our CPU. So I will see you then.